Hello class, today we're going to talk about the chain rule. Now one of the main principles of the chain rule is that if you take a composition of functions f of g of x and you differentiate it with respect to x, you're going to rewrite it as f prime of g of x times g prime of x. Now you can rewrite this with another composition of functions such as f of g of h of x, and the same principles apply except for one extra function. So you're going to write f prime of g of h of x times g prime of h of x times h prime of x. Alright, so let's try an example. Say we have the function x cubed squared plus 2. Alright, so when you're looking at this, you need to be looking for multiple functions. So what I see when I look at it is an x cubed and an x squared plus 2. Now, if you really like the power rule, you can simplify it to x to the 6 plus 2 and then differentiate it to 6x to the 5. But since we're using the chain rule, you can also do 2 times x cubed plus times 3x squared. And now that's going to get you the exact same answer, which is 6x to the 5. Alright, let's try another one. So, this function, when you're looking at it, you need to look for the two functions that are in the composition of functions. So what I see is an x squared and an 8x minus 2x squared over 3x minus 1. And we know to differentiate an x squared, we're going to have to use the power rule. And to differentiate the division of two polynomials, we're going to have to use the quotient rule. So let's go on our way and use the power rule for the outside function and the quotient rule for the inside function. So we know the quotient rule is low d high minus high d low, all over the low squared. Okay, so we're just going to plug in our values. 3x minus 1 times 8 minus 4x minus 8x minus 2x squared times 3. All over 3x minus 1 squared. I've gone and simplified this whole problem, and it looks like we're going to get an 8x times x minus 4 times 3x squared minus 2x plus 4, all over 3x minus 1 cubed. Now let's try a more proof-style problem. Say we're taking a derivative of an f of g of x squared. Alright, so this is a little bit tricky because it's a function that we know, which is x squared, an f of x, and a g of x. So we're mixing function notation with notation with respect to x. So we're just going to continue doing this as if it were a normal chain rule problem. So we're going to find f prime of g of x squared times 2g of x times g prime of x. Alright, let's look for some common mistakes that people make when they're doing chain rule. Now, one mistake that I make a lot of the time is when I'm differentiating, say, a x squared cubed plus 2, I will add the two numbers instead of, so I'll get 3x to the 4 plus 2x, as opposed to times. It's supposed to be times, but I will add them. So make sure you times the two numbers. Another mistake I see a lot, let's use the same example, is people won't differentiate this number. They'll keep it as a 2. So they'll get 3x squared times 2x, 3x to the 4 times 2x plus 2. And that's not right, because the derivative of a constant, as we know, is 0. So then we'll get a 6x to the 5. Another common mistake that people make is, say they're doing a d over dx of 2e to the 2t, and they're differentiating it, and they get a 2, using the constant multiple rule, 2 times e to the 2t, and that's it. Because they think that the derivative of a exponential function is just with the derivative of an exponential function with e is just the exponential function, but that's not true, because you have to factor in that this 2t is also a function and must follow the chain rule rules, so you'll get 4e to the 2t. You have to make sure you include this coefficient. Okay, class, thanks for watching my video, and good luck on my quiz.